It's Maths O'Clock with Mr. Hlajwayo. Welcome to another video. Greetings everyone. So now what we are going to be doing today is we are going to try and understand in terms of what is our similar right angle triangle theorem, right? So firstly, we're going to understand it in terms of its perspective. So now what it states, basically it states that now if you are having this line here, your perpendicular drawn line from the vertex of your right angle triangle, remember your TPR is your right angle triangle. If you draw now a perpendicular line to our TP, which is your hypotenuse, therefore it is going to divide these two triangles to be similar, which means now if you have drawn this perpendicular line from your vertexes or from your vertex of your right angle triangle to your hypotenuse, then it's going to cut these two triangles into being similar triangles, right? So this is what we are basically going to prove, right? So now let's look at in terms of what we are given. We are given that your angle R here is 90 degrees, and we are given that your RU is perpendicular to your TP, which means it cuts at 90 degrees. And if that's the reason, therefore, which means your U1 is going to be 90 degrees, and also your U2 is going to be 90 degrees because of what? Because of perpendicular. So now what we are required to prove, we are required to prove that your PRT is going to be similar to your what? Your PUR, which is also going to be your similar to your what? To your TUR. So basically that's what we are required to prove. So now what is it that we are going to do? So we are going to start here. Look, can you see that your U1 is equals to 90 degrees? So which means now actually if you have U1 which is 90 degrees plus your R1 plus your T1 plus your R1 is going to give you 90 degrees, because this is already 90, and this two must give you 90 degrees also because of sum of angles in a triangle, right? So which means actually your angle T plus your angle R1 is going to give you 90 degrees. The reason there, it's sum of angles in a triangle. This is what I've explained earlier. Now secondly, can you see that now actually your angle T is going to be equals to what? 90 degrees subtract your angle R1, right? So which means this is going to be your angle T. Similarly, can you see that your angle R1 plus what? Plus your angle R2. Can you see that these two given angles are equals to 90 degrees? This was given, right? This was given to us. So can you see that your angle R2 is going to be equals to 90 degrees subtract your angle R1 if you transpose this one to make your R2 a subject of the formula. So now look, we are saying this angle is equals to this angle, and this angle is equal to this angle. So which means automatically the last angle is also going to be equal, because if the two angles are equal, the other angles are going to be equal. I know this might not make sense, but to think of it, let's say here you have 90 and here you have 60. So can you see that automatically this is going to be 30 because of sum of angles in a triangle? Similarly, if we come into this triangle, if you have your R2, which we said is equals to your T at 60, and you have your U2 being equals to your what? Your 90 degrees. Can you see that automatically this angle is also going to be equals to your what? Your 30 because of sum of angles in a triangle. So therefore you can actually that now also from that particular narrative, therefore you can conclude that your angle P is also going to be equals to your what? Your angle R1, right? Now let's then continue. So which means now we are then going to try and prove similarity between the two triangles. So now we are going to firstly look at in triangle PUR. We're going to look at this triangle PUR and triangle TUR. These two triangles, right? So now we are going to say PUR So we are going to start here. Now can you see that TUR and also PUR, they share U? So you can actually say now your U1 is going to be equals to your U2. This is because they are both equals to 90 degrees, right? All of them are equals to 90 degrees. And what else you can prove? Can you see that in this triangle you have R2 and in this triangle you have T, and you've already proven here that these are going to be equal because they are equal to the same thing, right? So which means you can actually prove that your angle T is going to be equal to your angle R2, right? This is proven. Why are we saying this is proven? I mean, look here. T, it was equals to 90 degrees subtract R1, and R2, it was equals to 90 degrees subtract R1. So both of these triangles are equal to the same thing, so which makes them to be equal. I mean, so that's going to be your reason for that. And now let's then continue. So what is it that you're going to also conclude on? You're going to conclude that also your angle P in this triangle, your angle P, your angle P is going to be equals to your what? It is going to be equals to your angle R1. And this was also proven. So which means now what is it that you can conclude? You can actually conclude that actually therefore my triangle PRU, I mean PRU or PUR, let's write it as PUR, is going to be similar to a triangle TUR. What is going to be the reason there? Your reason there is going to be what? It's going to be because of all the angles that you have proven. So it's going to be your angle. And by the way, for similarity, the only feasible proof that you can do is proving that all the angles are equal, right? So now let's then look at the second one. So now we are going to say in triangle, let's try and shift this side. So now we are going to say in your triangle PRT now, in triangle PRT and triangle PUR. So now we are going to look at those two triangles now, PRT and triangle PUR. So can you see that your PRT now in this PRT, can you see that actually your angle PRT, look, PRT, let me, PRT, now PRT, can you see that this is going to be close to what? This is going to be close to your angle, I think this is going to be close to your angle U2. This because they are both equals to 90 degrees. I mean, PRT is the actual angle R1 plus R2, which is going to be equals to your angle U2 in this triangle. And what else then you can prove? You can also prove that in this triangle, your angle T here was equals to your angle R2. Your angle T is equals to your angle R2. This was proven. This was proven before. Then what else now you can also conclude? You can say now in this triangle your angle P is going to be common. Your angle P is going to be common. Look, you are looking at PRT and also this angle. Can you see that your angle P in both of these triangles is what? Is common. This angle is common. So now what is it that you can then conclude? So therefore you can actually conclude that your angle your triangle PRT is going to be also similar to a triangle PUR, right? Because of angle, 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 because of all these angles. So now, which means now, what is it that you can conclude? So can you see that you can conclude that actually all this side, your triangle PRT is going to be similar to your triangle what? To your triangle PUR, which is also going to be similar to your triangle what? RUT. I mean, because you've started by proving your PUR and TUR, and then you followed by PUR, PRT with PUR. So actually you have proven all the three triangles to be similar to each other. So now what is it that you can do now from here? So now you can express it this way. Look, so now if you can start by looking at the first two, so you can still conclude that actually your angle PR, so you can take PR here and which is also over PU, is going to be now say in proportion with your what? You take your PT here over what? If you've taken PT here, obviously here you're going to take what? You're going to take your what here? Your PR. So which means now this you can also express it in what sense? If you cross multiply, can you see that your PR squared, hopefully this is still visible, PR squared is going to be equals to your what? Your PU multiplied by what? Multiplied by your PT. So therefore, what else you can conclude on here? Look, if you come into this now, if you can say now your UR, now if you can come here and say therefore your UR over your what? Your UR, you see, you take this UR over UT is going to be equals to what? It is going to be the same as what? Your PU. You've taken this two now, so here you're going to take what? RU, and you see that RU is same as UR, so this you can still write it as UR, and therefore this is going to still give you what? UR squared, which is going to be PU multiplied by what? Multiplied by UT, right? Similarly now, if you come back and you say, all right, if I take my, hopefully this is still visible, if I take my RT over my UT, my RT over my UT, so I've taken what? I've taken RT over I've taken RT over my UT, so this is going to be the same as my PT over RT, right? Then this is going to give us what? This is going to give us, now if you can, you see that if we cross multiply, this is going to give us RT squared, right, which is going to be equals to your UT multiply by your PT altogether. So that is as far as our similar right angled